Hello everybody. So today we're gonna do an average weight problem. So basically in chemistry, the average weight is just basically the average of weights. And okay, that's a little bit like that doesn't explain anything, but hopefully this example problem will sort of sort that out. It says determine the average weight of chlorine. So basically, I guess there are two naturally occurring isotopes of chlorine. Now, what is an isotope? An isotope is an element, so chlorine has 17 protons. The number of protons are what determine the element that we're dealing with. So chlorine has 17 protons, but the level of neutrons that you might find in an atom of chlorine might vary. So one, it says, is Cl35. So this is the way they denote, they'll say like, let me write that a little bit bigger for y'all. They'll say like they'll say Cl35, and I'm just gonna write it like this. So this 17 right here denotes the number of protons, again making it a chlorine atom. This 35 is the number of neutrons and protons added together, and that's the mass number of chlorine. So there's Cl35 and there's Cl37. So I'm sure you guessed it. This will be 17, this will be 37. So we can tell that here there are 18 neutrons, and here there are 20 neutrons. Why? Because 37 minus 17 equals 20, and 35 minus 17 equals 18. So we want to determine the average weight, and it says that this occurs 75.53% of the time, and the average mass of this one is 34. You know what? I should probably just grab this. 34.96885. Oops. And that's atomic mass units, right? AMU. So now the other one occurs, of course, 24.47% of the time. And what this means, these two have to add up to 100 because there are only two isotopes that we're dealing with. So their total percentage has to be 100%. Now, what we have is this one, the average mass of this one is 36.96590 AMU. So they're basically saying how often they want us to calculate the average of this. So I know that my final value is going to be somewhere in between this and in between this. And because this occurs 75% of the time, about, my final average is going to be closer to this number than this number, right? Now, that's why it's a weighted average. I'll go ahead and write that down. Weighted average, right? So, basically, now they want us to calculate the average of this. Now, my teacher gave an example saying the average age in this classroom is about 18 years old, right? He might be 60 or 50 or something, but most of the people in that classroom were around the age of 18, meaning that if they were to take the average age of that room, it would be pulled toward 18. So that's sort of what we're doing here. So what we want to do to find the average mass of Cl, so I'm just going to write it like this. I'll just say average mass. This is going to be equal to, we're going to put that into a percentage. So 0.7553 times this, times the mass, and we're going to add that to the same thing here, 0.2447. I'll make these a little bit more visible for y'all. Times 36.96590, right? And when we add these up, what do we get? I'm going to plug it into my calculator here, and we should get a value. If I know that if this is outside of this range, I know that I've done something wrong. So let's see. 35.458 is what I'll say. And that's atomic mass units. And I want us to pay attention to something here. Let me just double check and make sure I got the right answer. Yes. So that is the value you're gonna see on the periodic table. So that's the value that they report for the atomic mass of chlorine on the periodic table. So basically, this is how you do a weighted average problem. And remember how I said that this value should be closer to 35? Well, 34.9697, then 37 about. That's what we have, because the average is pulled this way. So if anything wasn't clear, as always, feel free to leave a comment in the comment section. Please don't forget to like and subscribe, and let's keep learning chemistry. Thanks.